Alright, now that things are back to normal, or as much as normal is, it's time to go ahead and wrap up this semester. As I stated last week, while you were making up tests, you will not get another chance to focus solely on making up assessments. So just be sure you attack the following days with the same approach you did pretty much last week. You will have a 10-question assessment at the end of this week, which is Wednesday. You'll have another 10-question assessment next Wednesday, and a 3-question assessment Friday of next week. So keep in mind, again, every assessment must be taken twice, so you will eventually see those things pop up somewhere else. You just need to make sure you're ready for them when they do. So even though some of you are able to get 100% on the first assessment, and it will go on as 100%, at some point whenever we go to take that second assessment, if you don't take it or if you're not there whenever it's given that 100%, because it's 100% on the first one and a 0 on the other one, will turn to a 50%. Just like there are some assessments that I put in your progress reports and you only took it once, so I put the grade you had in there because I think that's the grade you can get. But in about a week or so, I'm going to be adjusting those for the fact that you didn't take the second one, which means your score will be cut in half. So just be sure to stay on top of it and use your time wisely more than anything else. In terms of what we're talking about, we've been looking at rate of change or slope since last week when I was giving you a few problems to talk about, and I gave you a table and told you to use the formula m equals y2 minus y1 over x2 minus x1. The y2 meant the second y, y1 meant first y, x2 meant second x, x1 meant first x. And so that's where we looked at the table. We put the second y in here minus the first y here, the second x here minus the first x there. We reduced the fraction, we simplified those values, reduced the fraction, found our answer. This formula is used whether we have a table or a pair of 2 points. So let's look at a couple examples just to make sure we understand what's going on. So one question you're going to see on the assessment, or pretty much overall, is they want the rate of change of a table. Again, what you can do here is, one of the things we did to find rate of change was we simply did second minus first whenever we did that. So we could do 40 minus 85 on top. And then we did the distance of these, which again, second minus first, 32 minus 23. And then in the end, you divide those two. Now notice that because our calculator has memory, as long as you do it in the right order, you can actually find the rate of change quickly as long as work is not needed, which you will be able to do that for the final as well as for the semester exam for the district. But in terms of on paper for the quiz, make sure you show me something in terms of where the numbers came from. So you will want to write, again, you don't need to write the y2 minus y1 over x2 minus x1, but remember that that usually represents x, that usually represents y. So yes, you do end up with 40 minus 85 over 32 minus 23, which is negative 45 over 9. When you reduce that, you end up with the answer of negative 5 as your rate of change. Or again, once you get those two answers taken at final, you could just take that number divided by the other number and get your answer that way. So the rate of change is negative 5. What does it mean? It means that the price, because we're talking price, drops $5 because it's cost. It's this per that. Remember that that line means per divided by. So it drops $5 per person. So whenever you're talking about that stuff, on the part, that's another thing they're going to want you to do. You find the slope, you understand what the slope is, but you want to make sure that you put the word. So this would be cost per, or cost per person, or cost per people. If we had days in column 1, cars in column 2, then our final result would be cars per day, because remember that goes on top, so it would be cars per day. So again, whenever you're looking at that, just keep that in mind. Find the slope of the line given, of the given points. Here again, what we've got is 2 points. The easiest way to deal with 2 points, especially if you like the table form, is just to transfer this into a XY table. So negative 924 goes there. This turns into 13 negative 20. And then we again go back to our y2 minus y1 over x2 minus x1. y2 is negative 20 minus 24. x2 is 13 minus, and I use this for a reason, it is not 13 minus 9, it's 13 minus whatever's in this box, which is negative 9. And so when you do your work, negative 20 minus 24 is negative 44. 13 minus negative 9 Make sure you practice typing that in so you know how to do it. It's 22, and in the end your rate of change is -2. So again, we did that already last week. I hope that you got a decent amount of practice to where you don't need to learn that from scratch this week. And the reason I did that last week is because that is honestly the toughest slope that you have to find. We can also find slope of an equation. In order to do this, we simply memorize and apply what we call the slope-intercept formula, which is y equals mx plus b. This is the actual formula that algebra recognizes. Many of us use the Demas formula last section to do dependent equals what I said was rate of change times independent plus the shift. That's really not the formula that it is. I just kind of use that to introduce you to it. So it is now time to let this formula go and deal with the universal formula. In the slope-intercept formula, m represents the slope, which we talked about, or the rate of change, and b represents your y-intercept, or as we'll talk about tomorrow, the starting amount. So again, that's pretty much what you're looking at whenever you're talking about the slope-intercept formula. I hope you wrote that down, because again, you're going to need this to study and prepare for your test on Wednesday. The application of slope-intercept is not major until next week, but for now let's make sure you've written enough notes to understand it for this week's assessment and quiz. What is the slope and y-intercept of the equation? So what you're talking about, remember, slope is m, y-intercept is b. It is in the formula y equals mx plus b. So in this case the slope is 6, and the y-intercept is this number here, which is -7. Just don't forget that negative. On the second one, again, if y equals mx plus b, in this case your m is -3, or your slope is -3, because remember that negative has to be respected, and your y-intercept here is again this number, or 2. Alright, so again, that's the type of question you're going to see. Just make sure you're ready for it. It shouldn't be that bad. Again, just take these notes with you and make sure you can answer basic questions, so that way I can help you whenever you come up. Because again, if you come up and you ask me how to do it and I say, what's the slope-intercept formula, and you say I don't know, I'm probably not going to help you. Now if you can at least give me some idea that you've listened to what's going on, I can help you. So just make sure you bring something to the table and I'll be glad to speak up for you. Final representation of slope comes from looking at the graph. You're going to be expected to understand a few things about slope from a graph. So again, just be sure you understand each of the following sections. Write down some notes to help yourself understand it, so that when you go up to these questions, again, they're not hard questions. You just have to actually do some pre-work to be ready for whenever the work pops up. One thing they're going to ask you is if a slope is positive or negative. Alright, so again, this is one topic that you're going to have to know. So whenever you're looking at the graph of a line, there is one simple test to determine whether the slope or rate of change is positive or negative. That should be a parentheses there. Write your name on the line. Because slope is read from left to right, it is the same direction as we read and write. So slope goes this direction, just like we read from this direction. So as long as we view it from this direction, we can tell whether it's negative or positive. So all you have to do again is observe the direction that your name goes, and that represents the sign of the slope. Now I'm not really going to sign my name, but again, just imagine signing your name on this line and notice that your line is going in a upward direction. This would be a positive slope. Again, if you imagine this line here and you signed your name on that line, notice that your name would be going downward, which means that it is a negative slope. So again, positive slope goes this direction, negative slope goes that direction, and that's really all you have to do to understand which one's which. Now you could put your name on the line, but again, whether you write your name or just kind of imagine writing your name, that's going to help you determine what the slope is. So just remember that. Again, write a note for yourself so you are ready for that when it pops up today. Another question they're going to ask you is which slope is greater. Okay, so which one has the greatest slope or the largest slope? If asked to compare slopes of two graphs, again, there's another imaginary test that can be used. All you have to do is imagine the line as a hill and imagine walking up that hill. So whatever slope would be more, or whatever hill would be more difficult, represents the greater slope. So in this one here, if we're walking up this hill, it's going to be a little bit of work because we're going up the hill. So this one has a slope to it that's probably not the easiest, but again, that's a hill. If we're walking up this hill, which I guess we can call it a hill, there is no slope at all, which means that that's honestly no slope at all, because, I'm sorry, zero slope, because it doesn't go up at all. It's just like walking on the ground. But if you were walking up this hill and you imagine this versus that, which ones of these would be the most difficult? This one would be, because in all honesty, I mean, it's you're pushing to get up that hill, so this one has the greatest slope out of all of them. This is the least, and this is the second most. Again, that is a decent hill to walk, but that is a really hard hill to walk, and so that's how you can identify a greater slope. The steeper the slope, the higher the slope. All right. Last question you're going to see is just going to say, what's the slope of the graph? Again, saving the most work for last. Finding the slope of a graph is simple as long as you start off taking it seriously. Again, we don't get another day to make up these assessments, so please make sure you work like you want to pass and that you want to have a passing grade, or a good grade at least. Use the practice problems a day to get a grasp of the material, and I don't think you'll have any issues with finding the slope of a graph. Choose not to approach it seriously today, and it will be a difficult one to get used to. So let's just go ahead and get used to it. Again, write down some phrases for me. Slope of a line is found using the phrase rise over run. So again, if you come to me with help and it's on a graph, I'm going to say, what's the phrase you use? You need to at least have rise over run in your memory, because I can work with that. This means, again, we count the steps going up and down as the rise, because of course that's your rise, and we count the steps going right. I didn't say left, but steps going right as our run. Alright. In the end, all we're going to do is create a fraction in which the values are simply substituted. So again, write that fraction also, because that's what we mean when we say rise over run. The rise number goes here, the run number goes there. That is our fraction. Think about how our slopes were. That was our y minus y, our x minus x. Notice y goes this direction, that is your rise. Notice x goes that direction, that is your run. So this kind of is an extension of these formula that we learned last week. Alright. Key thing on this, which is why there's an asterisk, and you probably want to write it down, is you always want to start from the leftmost point, and that will guarantee that your sign is correct. So what you will see is a slope like this, and it will ask you for the rate of change. And so you have a dot here and a dot here. The leftmost point is here. So what we're going to do is start here and first off determine what our rise is. So we have to figure out how far up or down to get to this point here, and notice that you make one jump. And it is a downward jump, so you will put a -1 in the rise position of that slope. Again, it's rise over run, which means my rise number is -1. Your run number is, from that jump, how far over do you have to go? 1, 2, 3, 4, 5. And so your rate of change of that line is -1/5. Again, down 1 over 1, 2, 3, 4, 5. That is your rate of change. It's just going to take a moment of practice again, but again, if you don't take it seriously, it's going to probably give you issues. On this one, here are your two dots. Again, leftmost point is here. My rise number is 1, 2, 3, 4 down, so -4. And 2 over, so a +2. You have to make sure you always reduce those rates of change, and so you end up with -2 being your rate of change there. Alright. The third one, again, dot here, dot there. First thing we want to do is our rise. In this case, to get here, we have to go up 1, 2, 3, 4, 5. That is a +5. And then we have to go over 1, 2, 3, 4, 5, 6, which makes our rate of change a +5, 6. Again, notice this was a negative slope. If I wrote my name on it, it would go down. This is a negative slope. If I wrote my name on it, it would go down. This is a positive slope. If I wrote my name on it, it would go up. So the slopes and our observation of slopes should always make sense in terms of what's going on. And then here, again, if I want the rate of change, I start from the left point, 1, 2, 3, 4, up, 1 over, which turns into just a regular 4. So those are the three things or key things that you need to be aware of today in terms of getting ready for that assessment on Wednesday. It's not going to be a tough assessment, again, as long as you do your job. So just do me a favor, go to MathXL and begin working on the first part of this week's assessment. Tomorrow should be easy as long as you do your part today. I am not going to give you a lot of extra homework, but again, this MathXL is preparing you for the assessment, so if you don't do it, you won't be ready for the assessment. So just be careful on that, and like I said, take it seriously, ask whatever questions need to be asked, and I think everything should work out just fine. Good luck.